Question 1. Integral x cube minus 7x plus 6 upon x square plus 3x dx equal to, we are given 4 options. First, we're going to divide the numerator by denominator. That we can write that as x cube plus of 3x x square plus 0x square minus 7x plus 6. So you're going to multiply by x. So we get as x cube. Sorry, this is x square. You get x cube plus of 3x square, which you get as minus 3x square minus 7x plus 6. Further, we multiply by minus 3, we get minus 3x square minus of 9x upon, we get as 2x plus of 6. So we get I equal to, we can write this as divisor, integral of x minus 3 plus 2x plus 6 upon x square plus of 3x dx. Further, we can simplify as x minus 3 plus of 2 x plus 3 upon x plus 3. Cancelling, we left with integral of x minus 3 plus of 2 by x dx. Integrating, we get x square by 2 minus 3x plus 2 log x plus c, which we see our answer matches with option A, that is x square by 2 minus 3x plus 2 log x plus c. Therefore, option A is the correct answer. Question 2. Integral log of x plus log x raised to minus 2 dx is equal to, we are given 4 options. We take I equal to integral of log x plus of log x the whole square dx. We integrated, we get integral log of log x into 1 dx plus of integral log x the whole square dx. You can write this as log of log x into x minus integral 1 upon x log x into 1 dx plus of over here it is 1 upon x log x into x dx plus integral log x raised to minus 2 dx. Further simplifying, we get x log x minus of integral log x raised to minus 1 into 1 dx plus integral log x raised to minus 2 dx, which for the solving we get x log x minus log x raised to minus 1 plus integral log x raised to minus 2 upon x into x dx plus integral log x raised to minus 2 dx, which is equal to x log x minus x upon log x minus integral log x raised to minus 2 dx plus of integral log x raised to minus 2 dx. Further, we get I equal to x log x minus of x log x plus c, which is our option, if we see, is matches with D, that is x log of x minus x upon log x plus c. Therefore, option D is the correct answer. Question 3. Integral tan raised to 5x dx equal to, we take I equal to integral tan raised to 5x dx. We can write this as integral tan cube x and tan square as x square x minus of 1 dx. For the solving this, we get tan cube x into sec square x minus of tan cube x dx. Over here also we take as dx minus of integral tan cube x dx. For the solving it, we get write as integral tan cube x into sec square x dx minus tan x into sec square x minus 1 dx. For the solving this, we get tan cube x into sec square x dx minus integral tan x sec square x dx plus of integral tan x dx. For the, we put t is equal to tan x, differentiating both the side, we get dt is equal to sec square x dx, where we get I equal to integral of t cube dt minus integral t dt plus integral tan x dx. For the integrating, we get tan raised to 4x upon 4 minus tan square x upon 2 plus log sec x plus c, which is, if we see, our answer matches with option B, that is 1 by 4 tan raised to 4x minus 1 by 2 tan square x plus log sec x plus c. Therefore option B is the correct answer. Question 4. If I is equal to integral cos 4x plus 1 upon cot x minus tan x dx is equal to k cos 4x plus c, then we're given 4 option of k. So take I equal to integral of cos 4x plus 1 upon cot x minus tan x dx. We write this as integral of 1 plus cos 4x upon cos x upon sin x minus sin x upon cos x dx. Further, we can write this as integral of 2 cos square 2x upon cos square x minus sin square x into sin x cos x dx. You can write this as integral cos square 2x into sin 2x upon cos 2x dx, which we can write as half integral sin 4x dx. For the solving, we get half cos 4x upon 4 plus c, which is half, the integral of sin 4x gives us minus cos 4x upon 4 plus c, so we left with 1 by 8 cos 4x plus c. So we compare this with k cos 4x, so we get k is equal to minus 1 by 8, which is our option C. Therefore option C is the correct answer. Question 5. Integral dx upon 1 plus 2 sin x plus cos x is equal to, I equal to integral of dx upon 1 plus 2 sin x plus cos x. We put t is equal to tan x by 2. Differentiating both the side, we get dx is equal to 2 dt upon 1 plus t square. Further, we know that sin x is equal to 2t upon 1 plus t square. And we have cos x. You can write cos x equal to 1 minus t square upon 1 plus t square. Substitute the values, we get I equal to integral 2 dt upon 1 plus t square upon 1 plus 2 dt 1 plus t square plus of 1 minus t square upon 1 plus t square. For the solving, integral 2 dt upon 1 plus t square plus of 4t plus 1 minus t square. You can write this as 2 integral dt upon 4t plus of 2, which is equal to integral of dt upon 2t plus 1 equal to log 1 plus t 2t upon 2. You can write this as log plus of c. Resubstituting the value of t back as tan x by 2, we get 1 by 2 log 1 plus 2 tan x by 2 plus of c, which is, if we see our answer matches with option C, that is 1 by 2 log 1 plus 2 tan x by 2 plus c. Therefore option C is the correct answer. Question 6. Integral tan inverse root 1 plus 1 minus x upon 1 plus x dx is equal to, we put x is equal to cos theta, where we differentiate both the side, we get minus dx is equal to sin theta d theta. If we substitute this, we get I equal to integral of tan inverse under root 1 minus cos theta upon 1 plus cos theta, this sin theta d theta. We take equal to minus integral of tan inverse under root 2 sin square theta by 2 upon 2 cos square theta by 2 into sin theta d theta. For the solving, we get minus integral tan inverse tan theta by 2 sin theta d theta. We can write this as half integral theta sin theta d theta, which is equal to half of cos inverse of x dx. Integrating, we get half of cos inverse x into x plus integral x upon under root 1 minus x square dx for the half of x cos inverse x minus of minus 2x upon under root 1 minus x square dx. Please note that we multiply and divide by minus 2, so we get x by 2 cos inverse x minus 1 by 4 into 2 under root 1 minus cos square plus c. Further, we can write this as half cos inverse x minus of under root 1 minus x square plus c, which is our option we see matches with b, that is half of x cos inverse x minus under root minus 1 cos square 1 minus x square plus c. Option B is the correct answer. Question 7. Integral tan inverse root x dx equal to, we are given 4 options. We put root x is equal to t. When we differentiate both the side, we get 1 upon 2 root x dx equal to dt. Or we can say dx is equal to 2t dt. We take I equal to 2 integral t into tan inverse of t dt. So we integrate, we take this as second part, we take this as first part. So we integrate this, we do u into v, so we get 2 bracket tan inverse into tan inverse t square by 2 minus of integral 1 upon 1 plus t square into t square by 2 dt. For the solving, we get t square into tan inverse t minus integral 1 plus t square minus 1 upon 1 plus t square dt. We take t square into tan inverse t minus integral 1 minus 1 upon 1 plus t square dt. For the solving, we get t square into tan inverse t minus t plus tan inverse t plus c. We can write this as, we take t as common or tan inverse as common. We get t square plus 1 tan inverse t minus t plus c. For the sorry, we get x plus 1 tan inverse. We resubstitute the value of t as root x back. We get root x minus root x plus c, which is our answer matches with option D. That is x plus 1 tan inverse root x minus root x plus c. Therefore, option D is the correct answer. Question 8. Integral x plus 1 dx upon x into 1 plus x into e raised to x the whole square equal to, we are given 4 options. We put t equal to x into e raised to x, differentiating both the side, we get dt equal to e raised to x plus 1 dx. So we take I equal to integral of e raised to x plus 1 upon x into e raised to x 1 plus x into e raised to x the whole square dx, where we get this as integral dt upon t 1 plus t the whole square. Further, we solve this as by partial fraction. We take a by t plus b by 1 plus t plus c by 1 plus t the whole square. Further, we have 1 equal to a plus 1 plus t the whole square plus b t and 1 plus t plus c t. Therefore, if t is equal to 0, then we get a equal to 1. If t is equal to minus 1, we get c equal to minus 1. When we solve the equation of this, we get a 1 plus 2t plus of t square plus b t plus t square plus ct. We can write this as a plus b t square plus of 2a plus b plus c t plus a. By comparing the coefficient of t square from, we get a plus b equal to 0, we get a is equal to minus b, therefore we know a is equal to 1, therefore we get b is equal to minus 1. Substituting this value, we get I equal to integral 1 upon t minus 1 upon 1 plus t minus 1 upon 1 plus t the whole square dt. For the integrating, we get log t minus log 1 plus t minus 1 plus t raised to minus 1 upon minus 1 plus c. Further, we resubstitute the value of t back as x into e raised to x. We get log x into e raised to x upon 1 plus x into e raised to x plus 1 upon 1 plus x into e raised to x plus c, which is our option, if we see, matches with a, that is log x upon. Therefore, if we see, there's a fine difference note in a option. The c is log x into e raised to x upon 1 plus x into e raised to x plus 1 by 1 plus x raised to ex plus c. Therefore, if we see, our option answer matches with option C. Therefore, option C is the correct answer. Question 9. Integral x dx upon 3x square plus 2 into x minus 2 d equal to, we are given 4 options. Let x by 3x square plus 2 into x minus 2 equal to a by x minus 2 plus of bx plus c upon 3x square plus of 2. We can write this as x is equal to a 3x square plus 2 plus bx plus c x minus 2. Further, we can write this as a 3x square plus 2 plus bx square plus cx minus 2 bx minus 2c. 3a plus b the whole square x square plus c minus 2b x plus 2a minus 2c. If x is equal to 2, we get a is equal to 1 by 7. Comparing the coefficient of x square and x, we get 3a plus b equal to 0 and c minus 2b equal to 1. So we get b equal to minus 3 by 7, c equal to 1 by 6 by 7 equal to 1 by 7, where we get I equal to 1 by 7 integral dx by x minus 2 minus of 3 by 7 integral x dx 3x square plus 2 plus 1 by 7 integral dx 3x square plus 2. Further solving this, we get 1 by 7 log mod x minus 2 mod minus 1 by 14 log 3x square plus 2 mod plus 1 by 7 root 6 tan inverse root 3 into x by root 2 plus c, which is our answer matches with option C. Therefore, option C is the correct answer. Question 10. Integral x square upon tan square x minus 4 tan x plus 3 dx is equal to, we given 4 options. We put t is equal to tan x. Differentiating both the side, we get dt is equal to sec square x dx. Further, we get I equal to integral of dt upon t square minus 4t plus 3 equal to integral dt upon t minus 3 into t minus 1. Further, we can write this as t minus 3 into t minus 1 equal to a by t minus 3 plus b t minus 1. If t is equal to 1, then minus half is equal to b. If t is equal to 3, then we get a is equal to half. Therefore, I is equal to integral of half upon t minus 3 minus half upon t minus 1 dt. For the solving, half of log mod t minus 3 minus of half of log t minus 1 plus c. So we get as half of log, we resubstitute the value of t as tan x, we get minus tan x minus 3 upon tan x minus 1 mod plus c. With this, our answer matches with option A, that is half of log tan x minus 3 tan x 1 minus 1 plus c. Therefore, option A is the correct answer. Question 11. Integral x cube minus 1 upon x cube plus x dx is equal to, we can write this integral as I equal to integral of 1 minus x plus 1 upon x cube plus x dx. So we divide the numerator by denominator, we get x cube plus x cube plus of 0 x square plus 0 x minus of 1. So we multiply by 1, we get x cube plus of 0 x square plus x, we get minus x minus 1. So we can write this as I integral of 1 minus x plus 1 upon x into x square plus 1 dx. We get integral of 1 minus 1 upon x square plus 1 minus 1 upon x square plus 1 dx. Further, we can write this as I equal to integral of dx minus dx upon x square plus 1 minus integral 1 upon x minus x upon x square plus 1 dx. For the solving this, we get x minus tan inverse x minus log x half of log x square plus 1 plus c, which is, if we see our, we further write this as x minus log x plus half of log x square plus 1 minus tan inverse x plus c, which is, we see our option B matches with answer. Therefore, option B is the correct answer. Question 12. The value of integral cos cube x plus cos raised to 5x upon sin square x plus sin raised to 4x dx is, again, 4 options. We can write the numerator as, that is, I equal to integral of cos square x plus cos square x the whole square upon sin square x plus sin raised to 4x dx. For the solving, we can write this as 1 minus sin square x plus 1 minus sin square x the whole square upon sin square x plus sin raised to 4x. We write this as cos x dx. Further, we put t is equal to sin x, differentiating both the side, we get dt is equal to cos x dx. We get I equal to integral 1 minus t square plus 1 minus t square the whole square upon t square t raised to 4 dt. Further, we write 1 minus t square plus 1 minus 2t square plus t4 upon t square plus t4 dt. We get integral t raised to 4 minus 3t square plus 2 upon t raised to 4 plus t square dt. Further, we make a fine adjustment in the numerator. We get t raised to 4 plus t square minus 4t square plus 2 upon t raised to 4 plus t square dt. That is integral. So integrating 1 plus 2, 1 minus 2t square upon t raised to 4 plus t square dt. Further solving this, we get integral dt plus of 2 integral 1 minus 2t square upon t square plus 1 dt. We get as integral dt plus of 2 integral 1 minus t square minus 3 upon t square plus 1 dt. Further, we get t minus of 2 upon t minus 6 tan inverse t plus 6. Resubstituting the value of t, we get sin x minus 2 sin x raised to minus 1 minus 6 tan inverse sin x. Sorry, this is c plus of c, which is our answer matches with option C. We see sin x minus 2 sin inverse x plus 6 tan inverse sin x plus of c. Therefore, option C is the correct answer. Question 13. Integral under root 1 plus x square plus x the whole square upon under root 1 plus x square dx is equal to, we give 4 option. We put t is equal to under root 1 plus x square plus x raised to n. Please note that there is a fine adjustment in a question. There is a mistake in a question. That is under root 1 plus x square plus x. It is the whole raised to n, not the n square, not the square. It is n. Therefore, for the solving, we differentiate both the side. We get dt is equal to n under root 1 plus x square plus of x n minus 1 into x upon under root 1 plus x square plus 1 by 1 dx. Further we can write this as n under root 1 plus x square plus x n minus 1 x plus under root 1 plus x square upon under root 1 plus x square dx. Further we can write this as dt upon n equal to under 1 plus x square plus x raised to n upon under 1 plus x square dx. Therefore we get I equal to 1 by n integrated dt is equal to t upon n plus c. You can write this as 1 by n and 1 by n under root 1 plus x square plus x raised to n plus c. If you see, our answer matches with option B. Therefore option B is a correct answer. Question 14, the integral dx upon 1 plus sin x raised to half equal to, again 4 options. So we can write the denominator part, that is 1 plus sin x, that is equal to under root of cos x by 2 plus sin x by 2 the whole square, which is equal to cos x by 2 plus sin x by 2. Therefore we can write I equal to 1 by root 2 integral dx upon 1 by root 2 cos x by 2 plus 1 by root 2 sin x by 2. For the integrating, further we can write this as 1 by root 2 dx upon sin pi by 4 cos x by 2 plus cos pi by 4 sin x by 2. 1 by root 2 integral of dx upon sin pi by 4 plus x by 2. We can write this as 1 by root 2 cosec pi by 4 x by 2 dx. For the integrating, we can write this as 1 by root 2 log of mod tan pi by 8 plus x by 4 mod plus of c upon half. Further, we can write this as root 2 log of tan x by 4 plus pi by 8 mod plus c. Our answer matches with option C. Therefore option C is the correct answer. Question 15, integral sin x plus cos x upon sin x minus alpha dx is equal to, we are given 4 options. We put t is equal to x minus alpha. We differentiate both the side, we get dt is equal to dx. We can, and x is equal to t plus alpha. We substitute this, we get I equal to integral of sin t plus alpha plus cos t plus alpha dt upon sin t. We can write this as integral sin t cos alpha plus cos t sin alpha plus cos t cos alpha minus sin t sin alpha upon sin t dt. Cos alpha minus sin alpha integral dt plus of sin alpha plus cos alpha cot t dt. You can write this as cos alpha minus sin alpha into t plus of sin alpha plus cos alpha log sin t plus of c. Further we get I equal to cos alpha minus sin alpha x minus alpha plus sin alpha plus cos alpha log of mod sin x minus alpha plus of c. Therefore, our answer matches with option A. Therefore, option A is the correct answer. Question 16. Integral dx upon cos x minus sin x equal to. We are given 4 options. We make a fine adjustment in the denominator. We can write as I equal to 1 by root 2 integral dx upon 1 by root 2 cos x minus 1 by root 2 sin x. We can write this as 1 by root 2 integral dx upon cos pi by 4 cos x minus sin pi by 4 sin x. For the 1 by root 2, we can write this as integral dx upon cos pi by 4 plus x. Further, we can write this as 1 by root 2 integral sec x plus pi by 4 dx. We can write this as 1 by root 2 log mod tan pi by 4 plus x plus pi by 4 upon 2 mod of plus c. Further, 1 by root 2 log mod tan pi by 4 plus x by 2 plus pi by 8 plus c. For the solving this, we can write this as 1 by root 2 log mod tan x by 2 plus 3 pi by 8 mod plus c. This our answer matches with option D. Therefore, 1 by root 2 log tan x by 2 plus 3 pi by 8 plus c. Therefore, option D is the correct answer. Question 17. Integral e raised to ax bracket fx plus f dash x upon a bracket dx is equal to, we are given 4 options. We put t is equal to ax, differentiating both the side, we get dt upon a equal to dx. We can substitute this, we get I equal to 1 by a integral e raised to t f of t by a plus of f dash t by a upon a dt. We can write this as d f of t by a upon dt equal to f dash t by a 1 by a, which is equal to 1 by a into f dash t by a. That is, we get I equal to 1 by a e raised to t into f of t by a plus c. Therefore, resubstituting the value of t back as ax, we get 1 by a e raised to ax into f of x plus c, which is our option. If we see, answer matches with option C. Therefore, option C is the correct answer. Question 18. Integral dx upon 1 minus x square raised to 3 by 2 equal to, I give 4 options. We put x is equal to sine theta. When we differentiate, we get dx equal to cos theta d theta. So we get I equal to integral of cos theta upon 1 minus sine square theta the whole cube under root d theta. We get integral cos theta d theta upon under root cos square theta cube. So we get this as cos theta d theta upon cos cube theta. For the integrating, we get sec square theta d theta equal to tan theta plus c. So we can write tan theta is equal to sin theta upon cos theta plus c, which we get as sin theta under root of 1 minus sin square theta plus c. Further, we resubstitute the value of sin theta as x, we get x upon under root 1 minus x square plus of c. With this, our answer matches with option B. Therefore, option B is the correct answer. Question 19. integral e raised to x into 2x cube minus 5x plus 10 dx. We use u into v and the following integration. We get 2x cube minus 5x plus 10 e raised to x minus of integral 6x square minus 5 e raised to x dx. For the solving, we get 2x cube minus 5x plus 10 minus 6x square minus 5 e raised to x minus integral 12x e raised to x dx. So we can write this as 2x cube minus 5x plus 10 e raised to x minus 6x square minus 5 e raised to x plus 12 x ex minus e raised to x dx plus c. For the solving it, taking e raised to x as common, we get 2x cube minus 5x plus 10 minus 6x square plus 5 plus 12x minus 12 e raised to x plus c. Therefore, we get as 2x cube 6x square plus 7x plus 3 e raised to x plus c. Which is, if we see, our answer matches with option A, that is e raised to x, 2x cube minus 6x square, 7x plus 3 plus c. Therefore, option A is the correct answer. Question 20, integral root e raised to x minus 1 dx is equal to, we are given 4 options. We put e raised to x minus 1 equal to t square. Differentiating both the side, we get e raised to x dx is equal to 2t dt. Further, we can write e raised to x equal to 1 plus t square. So we get dx is equal to 2t upon 1 plus t square dt. Further, we can write I equal to integral of 2t square upon 1 plus t square dt, which is equal to 2 into t square plus 1 minus of 2 upon t square plus of 1 dt. Further, we can write 2 dt minus 2 dt upon 1 plus t square, which is equal to, we can write this, the integral of this we get as 2t minus 2 tan inverse t plus c. We resubstitute the value of t back as root e raised to x minus 1. So we get 2 under root e raised to x minus 1 is 2 tan inverse e raised to x minus 1 plus c, which we get option as, if you see, if we take 2 common, we get e raised to x minus 1 minus of tan inverse of under root e raised to x minus 1 plus of c. Therefore, we see option B matches with our answer. Therefore, option B is the correct answer. Question 21, integral log x upon x cube dx is equal to, we are given 4 options. We take I equal to integral of log x into x raised to minus 3 dx. Therefore, we integrate, we get log x raised to minus 2 upon minus 2 into integral 1 by x into x raised to minus 2 upon minus 2 dx. For the solving, we get minus log x upon 2x square plus half integral x raised to minus 3 dx, which is equal to, we get as log x upon 2x square minus into, that is plus half x raised to minus 2 upon minus 2 plus c. Further solving, we get minus log x upon 2x square minus 1 by 4x square, which you get equal to minus 1 by 4x square 2 log x plus 1 plus c. Therefore, our answer matches with option B, that is minus 1 by 4x square 2 log x plus 1 plus c. Question 22. Let fx equal to sine square pi x upon 1 plus pi x. Then f of x plus f minus x dx is equal to, we are given 4 options. We use this function, therefore we substitute the value of function in this. We get integral sine square pi x upon 1 plus pi raised to x plus of sine square minus pi x upon 1 plus pi raised to minus x dx. For the solving, we get integral sine square pi x upon 1 plus pi raised to x plus of pi raised to x sine square pi x upon 1 plus pi raised to x dx. Further, we can write this as integral sine square pi x 1 plus pi raised to x pi raised to x dx. We can write this integral sine square pi x dx equal to as half of integral 1 minus cos 2 pi x dx. Therefore, we can write this as half x minus sine 2 pi x upon 2 pi plus of c. Therefore, we get this as x by 2 minus sine 2 pi x upon 4 pi plus of c. With this, we see our answer matches with option D, that is x by 2 minus sine 2 pi x upon 4 pi plus c. Therefore, D is the correct answer. Question 23. If an antiderivative of fx is ex and that of gx is cos x, then integral fx into cos x dx plus integral gx into ex dx is equal to, we have 4 options. So we have integral of fx dx equal to ex, which we get as fx equal to ex, and we have integral of gx dx equal to cos x, which we get as g of x is equal to minus sin x. Therefore, integral fx cos x dx plus integral gx e raised to x dx equal to, we get as integral e raised to x cos x dx minus integral e raised to x sin x dx. Therefore, solving this, we get integral e raised to x cos x minus sin x dx, which we get as e raised to x into cos x plus c, which is, we see our answer matches with option C. Therefore, option C is the correct answer. Question 24. Integral sin raised to 8x minus cos raised to 8x upon 1 minus 2 sin square into cos square x dx equal to, we have given 4 options. Make a fine adjustment in the numerator and denominator. We can write that integral sin raised to 4x plus cos raised to 4x sin raised to 4x minus cos raised to 4x dx upon sin square x plus cos square x the whole square minus 2 sin square x cos square x. Further, we can write this as sin raised to 4x minus cos raised to 4x dx. You can write this as sin square x plus cos square x sin square x minus cos square x dx integral sin square x minus cos square x. Further, we get this as minus of cos 2x dx, which is equal to minus sin 2x upon 2 plus c, which is our option we see. Minus sin 2x upon 2, we get answer as B. Therefore, B is the correct answer. Question 25. Integral x square upon a plus bx the whole square dx. We give 4 options. We put t equal to a plus bx. Differentiating both the side, we get, or we can make a final adjustment, we get x is equal to t minus a upon b. Therefore, differentiating, we get as dx equal to dt upon b. Now we take integral, that is I equal to 1 upon b integral t minus a upon b the whole square into 1 upon t square dt. Therefore, we can write this as 1 upon b cube integral t square minus 2at plus of a square upon t square dt. You can write this as 1 upon b cube integral 1 minus 2a upon t plus of a square t raised to minus t dt. Taking integration, we get 1 upon b cube t minus 2a log t plus of a square into t raised to minus 1 upon minus 1 plus of c. For the solving, we get 1 upon b cube a plus bx minus 2a log a plus bx minus a square upon a plus bx plus of c. Further, we can write this as 1 upon b square x plus a upon b minus 2a upon b log a plus bx minus of a square upon b into 1 upon a plus b x plus of c. If we see, our answer matches with option D, that is 1 upon b square x plus a upon b minus 2a upon b log a plus bx minus a square upon b into 1 upon a plus bx plus c. That is, therefore, option D is the correct answer. Question 26. Integral dx upon sin x minus cos x plus root 2. We make a fine adjustment in the denominator. We multiply and divide by root 2. We get as integral of dx upon root 2 sin x upon 1 upon root 2 minus of cos x 1 upon root 2. If you see, we take root as common over here, we get integral dx upon root 2 sin x into sin pi by 4 minus cos x cos pi by 4 plus 1. Further, we can write this as 1 by root 2 integral dx upon 1 minus cos x plus pi by 4. 1 by root 2 integral dx can be written as 1 minus cos 2 x by 2 plus pi by 8. This can be written 1 by root 2 integral dx 2 sin square x by 2 plus pi by 8. Further, we can write this as 1 by root 2 integral cos x square x by 2 plus pi by 8 dx. Further, this can be solved as equal to minus 2 by root 2 cot x by 2 plus pi by 8 upon half plus of c. we can write this as 1 by root 2 cot x by 2 plus pi by 8 plus of c, which is our option. We see answer matches with D, that is minus 1 by root 2 cot x by 2 plus pi by 8. Therefore D is the correct answer. Question 27. Integral cos theta log cos theta plus sin theta upon cos theta minus sin theta d theta equal to. We know that log cos theta plus sin theta upon cos theta minus sin theta equal to log 1 plus tan theta upon 1 minus tan theta, which is equal to log of tan pi by 4 plus of theta, as integral sec theta d theta is equal to half of log tan pi by 4 plus of theta. So we can write 2 sec 2 theta equal to d log dx tan pi by 4 plus theta. Further, we take I equal to integral log tan pi by 4 plus theta into cos theta d theta. You can write this as log tan pi by 4 plus theta sin 2 theta upon 2 minus of 2 integral sec 2 theta into sin 2 theta upon 2 d theta. For the solving, we get the answer as I equal to half sin 2 theta log tan pi by 4 plus theta minus half log sec 2 theta plus c, which is, we see our answer matches option D, that is half of sin 2 theta log tan pi by 4 plus theta minus half log sec 2 theta plus c. Therefore option D is the correct answer. Question 28. Integral e raised to x by 2 into sin x by 2 plus pi by 4 dx is equal to, we take I equal to integral sin x by 2 plus pi by 4 e raised to x raised by 2 dx. We can write this as, if we integrate directly, we get sin x by 2 plus pi by 4 e raised to x by 2 into 2 minus of integral cos x by 2 plus pi by 4 into 1 by 2 into e raised to x by 2 into 2 dx. Further, we can write this as 2 sin x by 2 plus pi by 4 e raised to x by 2 minus of integral cos x by 2 plus pi by 4 into e raised to x by 2 dx. Further, we can write this as 2 sin x by 2 plus pi by 4 e raised to x by 2 minus cos x by 2 plus pi by 4 e raised to x by 2 into 2 minus sin x by 2 plus pi by 4 half of into e raised to x by 2 into 2 dx. Therefore, this term indicates I, which we get in the past thing. So we can write this as I equal to 2 raised to ex by 2 sin x by 2 plus pi by 4 minus of cos x by 2 plus pi by 4 minus of I. Therefore, further it can be simplified as 2I equal to 2 root 2 e raised to x by 2 under cos pi by 4 sine x by 2 plus pi by 4 minus of sine pi by 4 cos x by 2 plus pi by 4. This can be written as I equal to root 2 e raised to x by 2 into sine x by 2 plus of c. But just if we see our answer matches with option D, that is root 2 e raised to x by 2 sine x by 2 plus c. Therefore option D is the correct answer. Question 29. If integral 2x square plus 1 upon x square minus 4 into x square minus 1 dx is equal to log x plus 1 upon x minus 1 raised to a, x minus 2 upon x plus 2 raised to b plus c, then the value of a and b are respectively. We are given 4 options for value a and b. So the integrated part we can write that as 2x square plus 1 upon x square minus 4 x square minus 1 equal to 3 upon x square minus 4 minus of 1 upon x square minus 1. Therefore we get I equal to integral 3 upon x square minus 4 minus x square minus 1 dx. We get this as, if we integrate this, we get 3 upon 2 into 2 log mod x minus 2 upon x plus 2 mod minus half of log mod x minus 1 x plus 1 plus c. Therefore, for the solving, log x minus 2 x plus 2 raised to 3 by 4 plus log x plus 1 upon x minus 1 raised to half plus c. Therefore, for the solving, we write log bracket x minus 2 upon x plus 2 3 by 4 into log x plus 1 upon x minus 1 raised to 1 by 2 plus c. Therefore, if we compare this with the given question, we get a equal to half and b equal to 3 by 4. Therefore, we see our answer. Therefore, our answer matches with option D. Therefore, option D is the correct answer. Question 30. Integral 1 plus x plus root x plus x square upon root x plus root 1 plus x dx is equal to, we can write that integral function as integral under root 1 plus x the whole square plus of under root x 1 plus x upon root x plus under root 1 plus x dx. We can write this as integral root 1 plus x, we take common, we get as root 1 plus x plus root x upon root x plus 1 plus root x dx. Sorry, this is under root of 1 plus root x. Therefore, we can write this write the integral part as 1 plus x raised to half dx. Integrating, we get 1 plus x raised to 3 by 2 upon 3 by 2. So this is 1 plus x 3 by 2 upon 3 by 2 plus c. Therefore, the final answer we get 2 by 3 1 plus x 3 by 2 plus c, which is our answer matches with option B. Therefore, option B is the correct answer.